Yeah. So the multiplicative inverse we are looking at, and this is how the condition is. So now, as we know, the GCD of these two numbers are 1. Okay. Can we find out the equations? How? Let us try to use the Euclidean algorithm. How does the Euclidean algorithm works? 43 equal to 17 into quotient plus remainder. This has to be equation number 1. Please tell me the values. The next step. Yes, guys, what is this quotient?
So we can write 2 and 9.
2 and 9. Okay. So this will come here, this remainder. So the second equation will be 17 equal to 9 into, cannot be 2. So 9 equal to 8 will come here, plus 1. This is the third equation. And this is your remainder, GCD. Because if you take the next one, this one here, you get the 0. As soon as you get the 0, Euclidean algorithm says previous is the GCD value. Okay. So this is the Euclidean. Now we have to find out the extended Euclidean. That means what? This can be rewritten as extended Euclidean algorithm says that GCD of 43 and 17. I'm sorry if it is not visible. Yeah. 43 and 17 can be rewritten as 43x plus 17y. Is it correct? Yeah, it is correct. So we'll start with the equations here, okay, to solve or to find out the values of x and y, okay. To start with this one. So GCD of 43 and 17 is 1, okay. So what we can do is we can rewrite this as 1 equal to 43 x plus 17y. So this we have to solve, right, to find out the values of x and y. Okay. What we can do is we will rewrite this equation, okay, as 1 equal to 9 minus 1 into 8. Okay, so we are just rewriting this equation as this one. Okay. So now we can actually substitute this value, 8 value, using equation number 2. So this is equation number 3. So we want to replace this 8. So we'll write 9 minus 1 into 17 minus 1 into 9. Okay, so we'll solve this further. We don't want to lose this coefficient. okay, because we want this in this format. Okay, so
okay, get ready.
I'm sorry. Sorry, there will be a lot of disturbance. Okay. So 9 minus 9 minus 9. No, this minus minus will be plus. So there will be 2 into 9 minus 1 into 17. Is it correct? Please tell me if I'm writing any wrong steps. I hope it is correct. 2 into 9 plus minus 1 into 17. Okay.
Yes, sir, it's correct.
Now we'll replace 9 with the equation number 1. Okay. So 2 into 43 minus 2 into 17 plus minus 1 into 17. Can you further solve and tell me the value of x and y?
X is 2 and Y is -5.
So x is 2 and y is minus
-5.
minus 5. Okay. Right. Right. So you have these values of x and y with the extended Euclidean algorithm. Okay. So now what we will do is we'll find out the multiplicative inverse with this solution. Okay, for that what you have is this equation. Okay, I'll start with this equation. 1 equal to 43 into the value of x is 2. Please tell me if it is if you have any other values of x and y. I'm assuming these are correct values. Plus 17 into minus 5. Okay. So can I take a mod operation on both the sides, left and right side? So 1 mod 43 equal to the whole right hand side also will take the mod. So 43 into 2 plus 17 into minus 5 mod 43. Okay. So and this equal to sign will change it to congruence. As you know, the congruence works on the modulo operation, right? So right now we'll work with equal to because on both sides we are writing mod operation. Okay. Congruence you should write by removing mod on the one side. So the same if you want to represent it with congruence, it will be 1 congruence this mod 43. Okay, this same thing, right? So let us solve this further. Okay, As the we have seen arithmetic operations of modulo, this mod operation can be taken into the brackets 43 into 2 into not mod into mod of 43 plus 17 into minus 5 mod 43. So I have taken mod for both the operations. Now can you tell me the value of the first item?
So it will be 0.
It will be 0. Why?
So because there is no remainder.
No remainder, because whatever the mod you are taking, actually the quotient, or what you can say, I'm sorry, divisor is a multiple of the same mod operation, so you will not get any remainder here. Okay, so now what is remaining is 17 into minus 5 mod 43. Okay, so can I rewrite this equation as 17 into minus 5 mod 43 equal to 1? I can write this, correct? Now if I, because I've just changed the side here, okay, if I want to use the congruence relationship here, so what I'm doing is I'm taking this one on the right hand side, so 17 into minus 5 equal to 1 mod 43. Okay, is it correct? If you have any doubts, please let me know. And this is actually the inverse one. So A into A inverse is equal to 1 mod, I'm sorry, mod 43. Okay, 43 is n here. So we have GCD of n and A as 1 that we have started with. N is 43, A is 17. Okay, so we have started with this, and we have got this as a equation, okay, which is similar to this one. So what is the 17 inverse? It is minus 5. Okay, so 17 inverse is minus 5, and whenever you don't want the minus negative value for the inverse operation, what you can do is you can take the mod operation. Okay, can someone tell me what is this mod operation, minus 1 mod 43? I'm sorry, minus 5 mod 43. We have seen the mod operations of negative numbers also. It is very simple. 43 equal to minus 5 into what? Quotient plus the remainder. So what is the remainder? Because mod operation works on the remainder. You can take the minimum quotient 1. The remainder in that case will be
38.
38. That is correct. Okay. So if you don't want the negatives, inverse, then other inverse is 38. So there are two inverse values that you have found in case one is negative. If suppose, and do you know what is this value? -5, you have got it from y. Okay, so whenever if you can write 43x plus 17y, actually y is the inverse of 17. Okay, so that is one thing. And if one value of y is negative, then you can get the other value of y as positive. Okay, so now can you solve the same? Can you check the whether you are getting the correct result or not?
Excuse me, sir.
Yeah.
Sir, I did not understand the how 38 came. Could you explain that part?
Okay. So what I want to know is, I want to know the A inverse. Okay. So what you know up till now is A inverse. That means A raised to -1. That means what? You are writing it as 1 by A, right? A gets cancelled and you get 1. Right? This is what you know up till now. Okay, but inverse in arithmetic, modular arithmetic, what it says is A into A inverse is equal to 1 mod n. You have to take the mod operation whenever you have the mod operation and you have the congruence relationship, then this A inverse is not this simple. Okay, so now what we have done is we have the values of A as 17 and N as 43. Okay, so in this case, what is the value of A inverse or A raised to -1? It is not, surely it is not 1 by 17. Okay, so what is that value of 17 inverse that I want to find out? Is the problem understood?
Yes, sir.
Right. Now, what I will do is I will keep trying the values of A inverse. Okay, because I know the value of A into something which will give me 1 mod 43. Okay, so can I go 17 into 1? Will I get 1 remainder if I do 17 mod 43? No, because 17 mod 43 is 43 minus 17. That is not 1. If I do with 2, 3, 4, 5, what is 17 into 5?
So 85.
85. Do you get 85 equal to 1 mod 43?
So 1 mod 43 will be 1 only, right?
1 mod 43 is 1. But you have to do is, so what is the congruence relationship here. Do you get 85 mod 43 as 1? Then only you can write congruence relationship like this. What is the meaning of this equation? 85 mod 43 is equal to 1 mod 43. This equation, you are rewriting it as this one, congruence relationship. That's what we have seen maybe a couple of weeks back.
Okay, sir.
So do you get that value? Do you get the value as 1 for 85 mod of 43?
Answer is -1. -1 you can get.
-1. So negative is should not be the remainder. Correct.
Yes, sir.
Right. But what if I do it with -5?
Then we can get 1, sir.
Yeah, so in that case, this will be -85 mod 43. I'm getting as 1. Okay, so that means what? If I'm multiplying 75 into -5, what I'm getting is 1 mod 43. Okay, that means what? This is the inverse of 17 when we consider the mod operation.
Understood, sir.
Okay. Similarly, if you go on trying all the values, just tell me, I'm sorry, just tell me the multiplication of 17 into 38 mod 43. Do the mod operation. Tell me the answer.
So we get 1.
You get 1.
So
So you can write it as this one. 17 into 17 inverse is congruent to 1 mod 43. So the 17 inverse value is equal to 38. I'm sorry, I have to take this call because there is an exam. Hello? Yeah.
sir, your mic is on mute.
I'm sorry. So I hope you have understood what is multiplicative inverse.
Yes, sir, I've understood.
But have you understood the process, how to solve the example?
Yes, sir, understood.
Okay, so first you have to do the Euclidean algorithm. You have to find out these equations. Next step is to find out extended Euclidean, the values of x and y. Okay, so where you are using these equations to find out these values. Once you have got the two values, what have you done is you have taken the mod operation on both the sides. Okay, this is just a testing actually. right? Because as soon as you solve this example, okay, or this equation, what you get is this is your multiplicative inverse, which you have already have got earlier. Okay, so what you can do is, as soon as you get the value of y, you know that it is the multiplicative inverse of a. I'm sorry, this one. Okay. If it is negative, then you take further mod operation of that value, okay, to get the positive one. Okay, if the value of y is positive, then there's nothing to worry. Okay, so that is one thing. So can you solve? There are plenty of examples that we have seen. So this is one example. You can find out the multiplicative inverse of 301. I'll give you the one more example. You have to solve that. I just got that from, yeah, this one. So we create the example here. So find out the inverse of 23. Okay, 23 inverse you have to find when the value of mod is 160. So the value of n is 160, the value of a is 23. Okay, and you have to find out 23 inverse. Okay. Obviously, what answer you should get? The answer is given over here. It is 7. Okay. Let me give you one more this thing. So we have seen multiplicative inverse. Now the new is Fermat's theorem. Okay. Now what does this Fermat's theorem says? Is a raised to p minus 1 is congruent to 1 mod p, where p is prime number. So this is what the theorem says. Okay, you just have to actually there is a proof of this theorem, which is quite lengthy proof, but we can apply the Fermat's theorem at many places where you want to find out the value of the large numbers. Okay, a raised to something else. So let me give you the values of a as 7 and p as 19. Can you solve this example? So 7 raised to 18 is congruent to 1 mod 19. That's what you have. Okay. So can you find out the value of 7 raised to 22 mod 19? Yes, anyone got the answer? So 7 raised to 4.
Is it 6, sir?
Sorry?
6.
6. Okay. 6. Is it correct? 6. Have everyone got this answer? 6. What is 7 raised to
Sir, I
4?
got 7.
Okay, there are more answers. Okay, what is 7 raised to 4?
2401.
What is this? 6, 7, or anything else?
Sir, it's 7.
Okay, let us fix the 7. Two have confirmed 7. So yeah, so the application of Fermat's theorem is to find out. Actually, what we are doing is we are working with the large numbers. Okay, these are very simple numbers. Whatever the numbers we are working on. Okay, the only problem is whenever we have to secure the public key and private key, you might have printed the public key, private key in the RSA. The length of that key is so large, 2000 bits or 1000 bits. And when you are doing these operations, it should be very simple, okay, to calculate. Now, if you ask a computer to do the operation, let's say, this is some number raised to some number. And let us consider that these are all prime numbers. Okay, I'm sorry, not this one. This one will be. So how to calculate this? Even the computer, let's consider these are the 100 digits, these are the 200 digits or something like that. So even computer cannot directly work on this. Computer also has to, or a processor also has to split it in the problems like this. Okay, so that it can calculate the values as in this way. Okay, so think about Fermat's theorem or Euclid algorithm or multiplicative inverse. You have to write the program in these fashions only, because there are some limitations of nowadays processors also, that they can't work with large number of digits. Okay, so If you want to solve these examples and provide a greater security, then you'll have to go through these Fermat's theorem, multiplicative inverse, Euclidean algorithm, and all these things. Okay, so these are some of the applications of what you can say the mathematical terms that we are looking at. Okay, the next mathematical term is Chinese remainder. We'll see that Chinese remainder next, maybe tomorrow. Okay, and I'll see the application also where can we use Chinese remainder. Any doubts for today's session?
No doubt, sir.
Okay, thank you. So let me just pull out the attendance for you.